Revelator John.
Hello, welcome to Revelator John. What affects aerodynamic drag? So if we consider the rotor blade as a lifting surface, or a wing on an aircraft as a lifting surface, they are designed to generate lift, and also the byproduct of that is they actually generate drag. So what affects drag? Well, there can be lots of different reasons. Okay, so one of the reasons is the actual shape of the rotor blade itself. So if it, or the wing. Now there are ideal shapes, but there are going to be differences. So it's basically that ability to deflect the air over the wing or over the rotor blade and create a streamed or smooth flow of air over that blade so that it meets at the trailing edge at the rearmost point of the blade, and so it can create a change in pressure over the blade which changes lift. Anytime there's a disruption or an interference or an inefficiency of that airflow over the blade, that's what amounts to drag. So if we have, let's say, a dirty surface or a slightly damaged surface, or the forward edge, the leading edge of the wing of the blade that might be damaged anyway, or it may have dirt on it, it might have pollution on it, it might have pollen on it, it may have ice. Ice is a big thing as well. That will disrupt the airflow over the wing or the rotor blade itself, which will affect the aerodynamic drag, which will increase it as well. Turbulence, any kind of turbulence, external turbulence, I'm saying here. Now, sorry, that airflow that is might disrupted over the blade, that will create turbulence near the surface of the blade, near what we call the boundary layer of the blade itself. So there's the form, the shape of the blade, but also the skin surface, what type of surface it is, that will affect the boundary layer, the boundary turbulence. If we consider external turbulence, so if we're flying in turbulent air, for example, that will affect the turbulence on the blade, affect that airflow over the blade, so that will affect aerodynamic drag. If we consider the differences of airflow over the rotor blade, for example, then we will have differences in lift and drag in forward motion. Okay, for a wing, if we consider an airplane wing, and for a rotor blade as well, towards the tip of the blade, towards the tip of the ring, we will have extra turbulence, which are specifically known as wingtip vortices. In essence, what happens there is that the air doesn't flow from the forward part of the blade over the blade to the trailing part or the rearward part. The air flows from beneath and flows over the edge of the blade. So you get this circular motion, which adds to turbulence, which adds to the increased drag on the blades as well. So these are all the things that can affect aerodynamic drag. It's the shape of the blade, the design of the blade, how clean the blades are, is there any pollution on the blades, any ice on the blades, any external turbulence, which you could argue it can be generated by weather, could all be generated by other aircraft, wake turbulence, that kind of thing. There could also be geographic turbulence, flying next to mountains, flying next to buildings, very close to buildings, that kind of thing. So we can have that kind of thing, that kind of turbulence that can externally affect the aircraft. You can also have situations where, especially in a helicopter, we can have what is known as a vortex ring state, which is an increase in aerodynamic drag, because there is very low forward airspeed, a high rate of descent. So instead of the air flowing, being induced above the rotor disc and forward of the rotor disc that goes through the rotor disc, we have such a high rate of descent that air starts to come up through the disc, thus creating more turbulence and creating more vortex action. And because that happens, as we start to try and arrest the rate of descent, we increase the collective, increases the pitch. That also tries to increase lift to arrest the rate of descent, but actually what that does, it also increases drag, So that will compound the problem even further. So that is aerodynamic drag. If we consider the profile of the aircraft and what was known as parasite drag, anything that is affecting the non-lifting surfaces of the aircraft. So if you consider the whole aircraft, the shape of the fuselage is designed so that it minimizes drag. But anything on there that increases drag or increases its profile to the airflow will obviously increase parasite drag. So for example, if we've got ice accumulation, dirt accumulation, if there's damage to the aircraft, if there is something sticking out from the aircraft for whatever reason, that will increase parasite drag. Now, so sometimes if we have extra bit of equipment bolted onto the side of an aircraft and the side of a helicopter, like a hoist or a camera or anything like that, you know, missiles, whatever it is, that will increase the parasite drag, so that will decrease the overall performance of the aircraft. But this video is more about aerodynamic drag, okay? The lift and the drag that is associated with the lifting surfaces of a rotor blade, an aeroplane wing, a horizontal stabilizer of a helicopter, an elevator off the side of the end of an aeroplane. Thank you.